Welcome to another TecNish with McNish. Today, I'm going to show you how to use the zero-touch provisioning security service from u-blox. This service securely and automatically delivers client certificates and keys to u-blox modules with root of trust-based security. These credentials are used by servers to validate the identity of a device as it connects, and this is a standard security requirement with all of the major IoT cloud platform providers. The credentials can also be managed over the lifetime of a device with options to renew, revoke, and reissue the certificates. Today, I'm going to show the process on my SARA R5 evaluation kit. Once the credentials are provisioned into the module, I'm going to onboard the kit as a device with AWS IoT to show just how easy the process can be. Let's get started. Once you've signed in to the ThingStream dashboard, the first step is to go to Security Services, ZTP Certificate Management, and create a root CA. Let's call this one TecNish 2-CA. Next, go to Device Profiles, also under Security Services, and create a profile. Let's call it TecNish 2-Profile. I need to select a plan, and I'll choose Security Standard. I'm using a SARA R500S, so to see the features available for that modem, I select it from the drop-down, SARA R500S-00B. I'm going to enable only zero-touch provisioning, and I need to select the root CA, and I'll use TecNish 2, the one that I just created. So this completes the one-time setup on the platform. Now it's time to provision credentials into my SARA R5 module. So I'll connect and power on my EVK. In mCenter, I'll select the COM port for AT commands, connect, and open the AT terminal. Let's get some info on my module. Now it's time to seal the device. I'll need to provide a device profile ID and a serial number. For the serial number, I'll just use the IMEI of my module. And the device profile ID I can get from the ThingStream platform. Since I've already connected my module to the network, I need to use the u-sec-con command to trigger a check-in with the security platform. This will enable the security features defined in the device profile, and since I have ZTP enabled, the certificates and keys will be provisioned. Seeing all zeros in the response to u-sec-dev-cert confirms that the modem has received the credentials. And I can now read out the private key, the client certificate, and the root CA. I'm going to go ahead and save these to my PC. I'm also going to create one additional file containing both the client certificate and the root CA certificate, and I'll use this later. So that's the complete zero-touch provisioning process. Now I'd like to show how these credentials and keys can be used to easily onboard a device to AWS IoT. The first thing I need to do is register my root CA with AWS. To do that, I'll need my root CA, which I already have. I've saved it from the module. And I'll also need something called a proof of possession certificate. The proof of possession certificate is generated from the ThingStream platform. And to generate one, you need a registration code from AWS. I'm using the AWS command line interface, and I can use the command AWS IoT get registration code. I take this code, and I provide it in the ThingStream platform to generate my proof of possession certificate. I'll download this. And save it here with the rest of my certificates. Now I can register my root CA with AWS. I'll also do this with the AWS command line interface with this command. AWS IoT register CA certificate. Then I provide the CA certificate as well as the verification cert. I will set this certificate as active in AWS. I'll also allow auto registration and pass a registration configuration file. Now that this is complete, if I go check my AWS IoT console, I will see that my root CA has been registered. Now I'm ready to onboard a device. I'm going to simulate a device with an external IP stack using the Mosquito MQTT client on my PC. I'm going to use the Mosquito client to publish some data. I need to provide the root CA certificate of the AWS server, which can be downloaded from AWS. I'll also provide the file containing the client and root CA, the client private key. This is my AWS endpoint. I'm connecting to port 8883, QoS, topic, client ID, TLS version, and finally the message that I'm going to send. The first time I try to connect, the server will disconnect right away. However, this has triggered the just-in-time provisioning process on AWS. So now I see that I have a certificate registered. That's my device certificate. And I also have a thing. Now that the device has been onboarded, I'm able to connect and send data to the platform. Let me set up a subscription to all topics in the MQTT test client. And now let me try that publish command one more time. And here, my data has arrived at the server. So that's it for today. Now you know how to use zero-touch provisioning, and I hope you also have an idea of how easy it makes onboarding a device to an IoT cloud platform. Thanks for watching, and see you next time.
you.